Welcome back to quantitative reasoning. Last time we learned how to make scatter plots that show the association between two variables, for example between the day of the year and wind speed. We plotted one variable along the x-axis and another variable along the y-axis. Sometimes we want to show in a single plot how multiple pairs of variables are associated with each other. For example, here's a plot that shows how the gross domestic product, GDP, of the United States and the Soviet Union developed between the years 1928 and 1991. The data are from the Groningen Growth and Development Center. We could make a multi-panel plot with one panel for each country, but a single panel plot makes it much easier to draw comparisons between the two countries. Let's download the spreadsheet gdp_USA_USSR.csv from the URL below this video. Then we import the data and shorten the name of the data frame to GDP. The data frame has three columns: year, the GDP of the United States, and the GDP of the Soviet Union. Our goal is to make a single plot that shows the GDP of both countries as functions of the year. There are different methods to make multivariable scatter plots with R. The method I'm going to show you isn't the most elegant from a programmer's perspective, but it's easy to learn and gets the job done. The idea is to break the task into smaller pieces. First, we make a scatter plot for only one of the two countries, for example the United States, with a plot function. Here I use the arguments main, xlab, ylab, and cex from our previous tutorial. Then we add the data for the Soviet Union to the existing plot. Because we want to show the data as unconnected points, we use the points function. If we wanted to connect the points by lines, we would have to use the lines function. The functions points and lines accept input coordinates either in the form x-coordinate, y-coordinate, that is GDP $year, GDP $USSR, or we can use the tilde operator with an optional data argument, USSR tilde year, data equals GDP. The sequence of the commands is important. First, we must run plot, and only then we can add the points or lines functions. There are several problems with the current plot. The data for the USSR are cut off at the bottom. It's confusing that the points for the USA and the USSR have the same shape and color. And we need a legend to distinguish between the data for each country. Let's fix these problems one by one. To make the data at the bottom visible, we can use the ylim argument of the plot function to expand the y-axis range. Next, we change the point symbol for the USSR in the points function with PCH. If you need a reminder about how to choose a numeric value for PCH, please have a look again at the previous tutorial. In this example, I'm choosing squares, but feel free to choose another point symbol. Right now, the squares are overlapping a little bit. We can cure this problem by reducing the size of the squares with the cex argument. Let's also change the color of the squares with the col argument, so that the data for each country look clearly distinct. We can add a faint grid with the grid function to improve readability. Right now, it would be unclear to a reader which symbol corresponds to which country. We can add a legend with the legend function. The first argument in legend specifies the legend's position. In our example, we can place the legend in the top left corner of the plot without obstructing any data point. The second argument in the legend function is a character vector that contains the legend text, in our case, the names of the two countries. In its current form, the legend is still useless because it isn't showing the point symbols. We add the symbols with arguments for PCH and COL that match the symbol types and colors in the plot. As icing on the cake, we can add trendlines with the lowest function from last time. There's a small complication when adding a lowest curve for the USSR, because some GDP data during World War II are missing. The trick is to remove the NA values first and only then apply the lowest function. I won't go into details right now. You can see the solution here or in the transcript at the URL below the video. This plot looks nice. Unfortunately, the procedure was a little bit tedious. For example, it would be nice if the legend automatically showed the correct symbol shapes and colors. There are free add-on R packages that have lots of these nifty features to automate this task, but the learning curve is quite steep. For our quantitative reasoning course, the basic method I've just shown you is perfectly adequate. Here are the main points of this tutorial. If we want to make a scatter plot or a line chart with multiple data shown in the same plot, we first use the plot function to show one dataset along the x-axis and another dataset on the y-axis. Then we add more datasets to the plot with the points or lines functions. We may need to adjust the coordinate ranges with the x-lim and y-lim arguments of the plot function. We should choose unique point symbols for each dataset. We must add a legend to communicate clearly which point symbol belongs to which dataset. The data in our example were relatively evenly spaced along the x-axis and y-axis. That is, we didn't have large gaps in some parts of the plot and dense clumps of points in other parts. Some datasets have more skewed distributions, so we may need to apply a coordinate transformation, also known as re-expression, before plotting them. We talk about re-expression in our next tutorial. See you soon.